Hi S3, hope you're all doing well. I've decided to put this video together because one or two of you have been in touch about the work involving coordinate points, so I thought I'd throw this together to try and just help you a wee bit further. So in recent lessons, the two things I've asked you to do with coordinate points is to be able to find the distance between them, which is basically the length of this line, and then the next one is the gradient, and that's obviously how steep this line is. So the key thing with this work is we need to know the change in the x direction and we need to know the change in the y direction. So a horizontal change and a vertical change. So if I look at this example I've done here, I've got the point 3,5. Reminder, what does a coordinate tell you? It basically gives you an x and a y value. So this 3 tells me I have gone along this x-axis to the point 3. And then the value 5 tells me I went up the y-axis to the point 5. So the coordinate 3, 5, 3 along, 5 up. That's what I've done. Likewise, this coordinate 7, 8. That means I've gone 7 along. So I went to 7 and then I went up to a value of 8. So in order to find the distance of this line, the key thing we need to do is we need to turn this diagram into a right-angled triangle. Because if I know this distance here and I know this distance there, I can use Pythagoras. So how do I get this distance here? Well, it's the difference between the 3 and the 7. It's the difference between this 3 and this 7. So in that direction, what's the difference between 3 jumping to 7? It must be a difference of 4. So that tells me that that's 4, that length. I'll change the colour of my pen for the other direction. So this distance here, well, I started at a point 5 and I've moved up to a point 8. So it's the difference between this 5 and this 8. And that difference is obviously 3. So we've got 3 there now. So now that I know two sides of my right-angled triangle, I can find this blue line by doing Pythagoras. So a reminder about Pythagoras, if I call this length x, I know my distance x squared is going to be 4 squared, because that's my horizontal change, plus 3 squared, which is my vertical change. So now I can just calculate this. I get 16 for 4 squared, 9 for 3 squared, add them together for 25, but that's x squared. I want x, so I'm going to square root 25, and I get an answer of 5. So that's how I find the distance. Use the points, find the difference between the two x values to get your horizontal change, and then the difference between your y values to get your vertical change. And then you can use that with Pythagoras. The gradient, you've done a lesson on gradient which says it's the vertical change divided by the horizontal. If I'm talking about coordinates, which direction is vertical? It's my y-axis, so it's basically my y change over my x change. And it's given with this mathematical formula. But we've already worked out what is the difference in the y direction. It's this 3 here. So if you do this method that I did, where I just looked at the points, all I need to do is I just need to do my vertical change over my horizontal, which is 3 over 4. If you're using this mathematical formula, y2 is just the y value of your second point. So it's this value of 8 here. It's the second point y value. Remember, the second one in your bracket is your y value. So y1 is the 5. That's the y value of my first point. So if I was using this mathematical formula, y2 we've said was 8. So I would take away 5 from that. What's x2 going to be? Well, it's the x value of my second point, which is 7, and I'm going to take away from it the x value of my first point. But you'll see when you do 8 take away 5, you get 3, and when you do 7 take away 3, you get 4. And we actually get exactly the same answer here. So you can use this mathematical formula if you want, but I prefer just a quick way. So I'll just do another couple of examples just to show you how to find the distance and gradient between 2 points. So another couple of quick examples then. I've got these 2 points here. I'm going to do exactly what I did last time. I'm going to find the difference between the x values. So that's the difference between 3 and 8. Well, to go from 3 to 8, that's a difference of 5. And what about my y values? Well, to go from -2 to 10, that's a difference of 12. So it's these two differences then that I can use to find the distance. So I'll just call that d. And we know that the distance squared using Pythagoras is going to be 5 squared plus 12 squared. 25 plus 144 is 169. And then to find that distance, square root that answer, and I get a distance of 30. So again, that's just using the 5 and the 12. So to find the gradient now, I'm not going to use the formula. I'll do it just in a second. But all I do is I basically use my vertical change divided by my horizontal change. That's the change in the y coordinates divided by the change in the x coordinates. So here is my change in the y coordinates, because they're the second values in the bracket. So I had 12 over 5. I could make it a decimal if I want, but there's no point. If you are using this formula, then y2 minus y1 over x2 minus x1. Wee reminder, y2, the second point, y value. So I get 10 minus the first point, y value, which is minus 2. And then x2, x value of my second point, which is 8. Take away x value of the first point, which is 3. But all I get here is 10 take away -2 is 12. 8 take away 3 is 5. I get 12 over 5 again. So I've already got it here. So yes, you can use this. It gets confusing when there's negatives. So I much prefer just this method I've shown up here. So we'll do one more example. Find the difference between the x values going from -1 to 7. That's a change of 8. And going from -7 to -13, that's a change of -6. And it's quite important you pick up that negative change. So now for the distance, it's these two values squared and added together. I get 64, I get 36 here, because negative times a negative just ends up being positive. So we get 100, and then to find d, I'm going to square root that, and I get 10. For the gradient, yes, you can use this, but what I'm saying to you is if you've done this work here, there's my y change, which is -6, divided by my x change of 8, and I get -3 over 4 when I cancel this down. What does this negative gradient tell me? Well, it tells me my line is going to be going downhill from left to right. So hopefully that's helped to clarify a few things. If there are still any problems, anything that's not clear, please get in touch either through Teams or email, and I'll endeavour to get back to you as soon as I can. Hope we're all well, enjoying the snow, and hopefully we'll be back together in the classroom soon.